Hi there, and welcome to this video where we're going to go over an angle of elevation word problem as requested on Wyzant. And here we have the actual question. And I thought that the video would be a better approach to this because I think drawing pictures are pretty fun, and this is really an effective way of seeing what's going on in the problem. So that's why we have this video in this image here. Okay, so let's read through the problem again. We have a boat has the angle of elevation to the top of a lighthouse is 7 degrees. So they tell us what type of angle situation it is, angle of elevation, and we know that when we say elevate, we're moving in an upward direction. So that's why you see that arrow right here is moving up. It's turning up like that. Now the tower itself is 51 feet high, and they want us to find the distance from the lighthouse, from the boat to the lighthouse, given the angle of elevation. So all of that's tying in together to relate to that distance, basically how far out the boat is from the lighthouse, whether it's moving in or out. And then they want us to round the answer to the nearest tenth. So just to have some rule there on approximation. Okay, so again, drawing pictures for these type of questions, really nearly any type of word problem is really, really effective because you're putting the visual out on paper or on screen in front of you. And so I'm a big advocate of this. Doesn't matter if you're an artiste or you don't really care to draw, but it's like, hey, give yourself that visual to help. And parts of this, notice my boat is like really simple looking. My lighthouse is a little bit more, active, but yeah, doesn't really matter how exactly it looks. Just give yourself that image. Now, because I had worked it out separate or outside of this video, I kind of know what how the picture should look given the answer. And you can kind of tell even with the first piece of information, when they describe the angle of elevation as 7 degrees, then that should kind of give you an idea how or that the boat is really far out, because the boat isn't necessarily the angle in which the boat is reaching to the top of the lighthouse isn't that big. So that means there's a lot of space in between, and you're going to see that play out in a moment. So let's actually get into the math. And of course, the first thing you want to figure out is, well, what type of approach do we take? And if this is an Algebra 2 class for sure, then you've seen a lot of different approaches to problems dealing with triangular figures. And that's what we have here, right? We have a triangular shape, given the positions of each thing, right? We have the boat, we have the lighthouse, and then we have the distance in between. So that's going to give us 3 sides, 3 points. Okay, so whenever we're dealing with triangles, we have a number of different approaches, but one of the biggest ones that takes up a whole subject is trigonometry. And the question here is, well, what type of trigonometric procedure do we apply here if it would be trigonometry? And that's really going to be based on the information. A lot of the times in math, the information you're given will lead you to the approach pretty much. So because we have 2 sides, the fact that the lighthouse is 51 feet, and then we have the distance is x, but we don't know what the third side is. However, we have an angle, right? And we tend to call it theta, which is 7 degrees. These 3 pieces tell me that I can use a trig ratio, right? So there's the big 3 that we know of. We have sine, cosine, and tangent. And if you remember SOHCAHTOA, then you recognize what each of the ratios are. And I noticed I wrote rate instead of ratio. Let me fix that real quick. But it's pretty much the same thing. All right. So for sine, we know that this is opposite over hypotenuse, the opposite side of the angle. Like in this case, we have an angle opposite of the lighthouse. So that's kind of halfway to, our setup. Cosine is the adjacent side over the hypotenuse. And again, we know adjacent means to the side. That's what adjacent literally means. So when we talk about an adjacent side, we're looking at where the angle is that we're using. And we're never using the right angle. We rarely ever use the right angle. So it's always going to be the other two angles. So in this case, we have a side that we're using, or that necessarily we're looking for, adjacent to the angle 7 degrees. So that's going to be x, right? And then we finally have, for tangent, opposite over adjacent. Okay, so at this point, this should hopefully, bring in that recall, looking at those ratios, right? Like which one would fit this scenario, right? So if you want to pause the video and, go at it again and solve it, and then come back to this video to see what the result is, then that is really, really awesome, because that way you're trying it out for yourself and seeing, can I get this on my own? Which you definitely can. All right, so go ahead and try that. I'm going to keep going though. And so you can already tell with my arrows that we have an opposite side and an adjacent side. We don't know anything about the hypotenuse. And if we did, we wouldn't necessarily need to use the trig ratio, right? We wouldn't have to use or depend on the angle. We could just use Pythagorean theorem. So in this case, we don't have that. We have to use the trig ratio, or one of these trig ratios, right? So because of its opposite over adjacent situation, this tells me that we're going to use tangent, right? That's the ratio that we're going to apply here. And that's, at that point, you're, pretty much setting up to move forward and solve. So now we're going to fill in the pieces that we have. We have the opposite side, we have the adjacent side, we have our angle, and it's in degrees. And that's another important piece to the situation, is knowing whether you have it in degrees versus radians, okay? I'm not going to get into that in this video, but just bringing it up to remind you that that's something important to pay attention to as well. All right, so now that we have our setup, the initial step to our setup, now we just have to work through it algebraically. So we have 51 feet over x, also is going to be in feet, equal to tangent 7 degrees. So now we have to isolate x, because we can't necessarily know or see what x is in that position, right? So we're going to start off by simply multiplying both sides by x. That way x is canceled on the left there, leaving 51. I'm just going to drop the units for now. And we have tangent 7 theta times that x variable. So now we just have to divide both sides by tangent theta, tangent 7 degrees on both sides again. And then we have officially, successfully isolated x there. And this is the expression is equal to, right? And we simply need to just plug this into any calculator. If you have a TI-30, I think that should still work. TI-30s are simply scientific calculators, not that it's totally simple. Graphing calculators, so TI-84, TI Inspire. Casios also have the functions to, work with this type of problem. You can do trig ratios on there. But let's say you don't have a handheld calculator. You can totally use Desmos here. That's actually what I did, because I didn't have my calculator handy. So we're going to definitely do this for the video, okay? So we're going to just make sure that our settings are in place. The main thing is making sure we have the right angle setting. Remember, it's either degrees or radians. So we want degrees, of course, because that's what's handed to us. You can totally use radians, but you would have to turn that degree value into radians. That's the only thing, okay? So we're going to put it in radians, have it that. Same thing with calculators. And now we can go ahead and type this into that calculator. So we're going to do 51 divided by, here's our tangent function, and we just type 7 and we're done. And you can see to the far right here, our answer is 415 point da 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 da. There's a bunch of decimals, okay? Since they want us to round to the nearest 10th place, we're going to round that 3 there right after the decimal up to 4. So that's going to be our answer. Okay, so the distance from the boat to the lighthouse is 415.4 feet. Okay, and again, that makes sense, right? The angle of elevation is really small, right? So that means it's pretty far out. That's why I was able to draw that picture like that. It's probably, you could probably make it even more drastic looking, just so you have a good understanding of that visual. All right, so there's that as it relates to the problem, and I hope you found this video helpful. Definitely let us know if you have any more questions.